In this section, we're going to explore kind of a strange idea called a short circuit. Hey, once again, we have a series circuit, single path, 3 bulbs, and there it is. We notice they're, not super bright, moderately bright. If we check the current once again, I'll open the switch, put the current meter in. We still notice the current is about 0.17 amps, so about 17.17 amps with all 3 bulbs in the picture. Now the charge is just only has one path to go in, but the question is, what happens if we get out a wire and we provide another path? So strangely, instead of the wire or the charge having to go through this whole route, I'm going to take this wire, and while the circuit is turned on, I'm going to put it across this first bulb. In fact, I'm going to use a shorter wire so it's easier to see. Watch what happens when I put this wire here. Notice, this bulb turned off. These 2 bulbs got brighter. Let's do it again. We'll take it off. 3 bulbs, about the same. But when I put it across, now this bulb goes off and these bulbs come on. If you're at charge and you're coming along this wire, hey, you've got a choice to make. You could go through the bulb. It's pretty hard to get through there. It has a lot of resistance. Or you could just go through this wire. And it looks to me like most of the charge goes through this wire and not much goes through the bulb. This is known as a short circuit. We've shorted the path and made it so the charge doesn't have to go through this bulb. Just to comment on the name short circuit, short happens to be what happens here. It seems like this is physically shorter. It's less distance than that. But I want to show you something. What if I do that very same thing, but instead of this little short wire, what if I use this big long wire? Look at this. I'm going to put it in here, and then I'm going to connect it just like I did before, and notice what happens. Oh, it still did exactly the same thing. This bulb went out, these bulbs got brighter. It looks like I actually made a longer circuit, but the point is the word short circuit doesn't mean physically shorter, it just means easier. It might be better to think of it as an easier circuit, but physicists tend to call it a short circuit, so we'll stick to that. But notice, when I have this extra wire in here, what do you think happened to the current? These 2 bulbs are brighter. The current had been 0.17 amps. Let's check and see. With the short circuit wire in there, look, now the bulb is the circuit is 0.2 amps. In other words, the current is increased by putting in the short circuit. Now we can do this again. I'll turn the circuit back on, but instead of jumping just 1 bulb, now they're all 3 on, let's go and jump over 2 bulbs. What's going to happen now? Think about this. I'm providing another path for the charge. It can essentially skip those 2 bulbs. Watch this. Whoa! This bulb's super bright, but these 2 bulbs have effectively gone out. Again, you're a charge, you're coming along. What do you want to do? Do you want to go through this bulb and make light, this bulb and make light, or zoom, just go through this wire where it's easy? This is the easier path. You think of it as an easier circuit, but of course the physics name we use is a short circuit. And again, let's check the current just to see. So the current with a single bulb, wow, it's back up to 0.28 amps. 0.28 amps. So the data to collect here is that with only 1 bulb and the other 2 short-circuited, 0.28 amps. If we short circuit just across 1 bulb, we're at 0.20 amps. And if we don't let this wire go anywhere, or I take it out altogether, now we're back to our standard 0.17 amps. So short circuits, they are ways to make the charge have an easier time, but they can be dangerous. Because if suddenly you increase that current, sometimes you can increase it too much. In a house situation, this might be the time when a fuse or a circuit breaker gets blown because you cause too much current. This bulb can handle it, no problem. But if we put too much current through a circuit, something could get hot, something could start on fire, and circuit breakers and fuses, which we'll talk about later in the course, are designed to prevent that problem. Alright, so go ahead and use this information to answer the next series of questions about short circuits.